Okay, hello everyone. Welcome to my session, listening about my journey about organizing and backing up a pretty huge collection of photos. The main issue that I'm solving here is something that quite many of you probably know. So you take a photos with your camera, copy the files from the camera to USB drive, and then put the drive somewhere in a wardrobe. And for the past few years, you probably have even multiple of those drives, and maybe someday you get back to some Christmas photos or pictures of your cats and dogs, but you rarely do that. So I was thinking that maybe there's some way that I can back up these photos more securely and have those have some better way of going through the collection. And what makes this a little bit harder for us is that we have, well, over 5 terabytes of these photos at the moment. The main problem is, well, this person here. She's Eija. She's a freelancer photographer, and during the past few years she has taken some pretty stunning photos of dancers, models, weddings, children, and whatnot. And so during the years she have gathered a collection of a few 100,000 photos, over 5 terabytes. So when I moved in with her, I decided that, hey, I can fix this thing for you. It shouldn't be that big of a deal, just backing up the data somewhere and organizing it somehow. And why me? Well, I'm a full stack developer. I've been doing work on AWS serverless tooling for the past 4 years. I live here in Jyväskylä, Finland, and work at Nordcloud. We are a cloud company doing business with AWS, Azure, and GCP, doing design, cloud native application development, and then also managing large-scale infrastructures, doing lift and shift from on-premises to the public cloud and whatnot. So yeah, cheap and scaling backup solution shouldn't be that hard because there's lots of tools that you can use. Pretty cheap, some of even almost free, and just pick one and live happily ever after. Or than not. So the business requirements were that it should be easy to use, that we just copy the files somewhere and then the magic happens and then we can browse those photos, and those are also backed up somewhere. It should be cheap, like 10 to 20 euros per month is the maximum we could pay for this. The storage should be really durable. Like we don't want to end up in a situation where the service provider that we are using will go, for example, bankrupt and end their service. So we would have to download everything and move to some other place. So we want to keep with these big players that we are sure that will be there and for example won't increase their pricing, at least not significantly. And also, as said, we want for the browser, so some way to browse those photos more than just going through the folders and going through the images one by one. So the first iteration of the backup is just, we have a local network drive at home, copy the files on it, and it will put the data into the cloud. Simple as that. So when I started going through these different services, what could be used for a backup, I first thought that maybe Google Drive would be good for this. Well, 2 terabytes costs 10 euros on a Google Drive, but then if you need more, you have to buy 10 terabytes that will cost 100 euros. So there's quite steep curve on the pricing there. So yeah, Google Drive not an option here. Then maybe Dropbox, since we are using that for document storage already. Well, for individuals, the maximum you can get is 3 terabytes. So that is not enough here. And the next step is for teams. You get as much space as you need. However, you have to buy a multiple of these user licenses. So yeah, it will end up costing quite a lot. Well, the next was maybe just use the S3, since we are doing this cloud business here. So for the regular tier storage on S3, it will cost 2 cents per gig. So with 5 terabytes, that's 115 euros. So yeah, that's just too much. Also, there's no thumbnails or preview images from these RAWs if we just put those files somewhere. The galleries are hard to browse because those would be just directories and images there, and we would have to go through those like one by one. And also it's, well, missing some kind of magic here. But first, solving the 5 terabyte storage issue. So we have these 5 terabytes of raw images, raw files that we really need to have backed up somewhere. Luckily, there's a Glacier Deep Archive storage tier on S3, so that's quite a lot of cheaper than regular S3 storage. So with the 5 terabytes, with that pricing, it's just $5 per month. So that's like solving most of our issues here with the storage. So it's really, really cheap. There's basically unlimited storage. The downsides are that, well, there's a retrieval price. So if we need to download the data back, it will cost like 2 cents per gig. And also there's a retrieval time, so we cannot instantly just download the files. Instead, we have to wait for a few hours before we can start the download process. However, this doesn't really matter that much, since this is only for the worst case scenario. So if the local network drive completely fails, or if house burns down, then we have bigger issues than just the photos and backups. But at least we have the backups and we have some way of getting those back. So the cloud backup solution 2.0 is now that we have this local network drive, then we have raw files in S3, and then we need some additional magic, and then in the end we will have the photo browser ready to use. Yes. So the next step, extracting the JPEG from the RAW. So RAW files, we just cannot view those straight away from the browser, especially because those are in a deep archive. But luckily there's a way to get the raw image, the JPEG image from the RAW. So first, when we upload the RAW to the S3, we can use EXIF tool to get the preview image. Then also we can copy rest of the EXIF data, for example, GPS, shutter speed, and well, any kind of data that camera provides. And then we can use image magic to resize the image to, well, good size image for a photo browser. Yeah, but those EXIF tool and image magic, those are native binaries, so getting those up and running in a Lambda function, well, it is possible, but well, sometimes you are lazy, especially when doing these personal projects. And then again, these raw files are quite huge, and those take quite a long time to process. So I thought that maybe I don't even try to fit those in a Lambda function. It would be doable, and if I would be doing this for an actual customer case, I would do it. But yeah, now it's just simple because I have Raspberry Pi at home, and that's already handling the local network drive data. So with a small bash script, I can extract the preview image from the raw file, copy all the tags, copy the EXIF data from the raw image inside to the JPEG, and then resize the JPEG to good size. And then we can sync these thumbnails or preview images to another S3 bucket that is running on regular tier S3. So price for that, the storage price for that is 2 cents per gig. And since these photos are so small for these few 100,000 photos, it will end up costing just around $1 per month. So now the Cloud Backups Solution 2.0, we copy the files to the network drive, and then we have the Raspberry Pi handling the resize and syncing. So then, the rest of the magic, and this time it really is magic, and that magic is provided by, well, what else than AWS recognition. With the recognition, we can recognize all the faces from the photos, so we can find the same person from different photo shoots. So if we want to only look, for example, pictures of myself, I can click on myself from one image, and then I'll see all the pictures where I am and only view myself. Then it also provides object and scene recognition, so you can browse photos by occasion. Let's say you have cat photos, so you can only view pictures of cats. Or if you want to see all the weddings that you've been in, you can select tag wedding, and then you get all the photos that are tagged with wedding. So here it is, what it looks like from AWS console. So if you can drag and drop image there, run the recognition, and it will give you the result. So for example, here there's humans wearing clothes. Luckily, next to the water, there's some kind of waterfront. And then here we have dance poses and nightlife and people on a stage. Yeah, unfortunately, Magic isn't free, so you will have to pay for it quite a lot in this case. The price for running the recognition is $1 per 1,000 images. So with this 5 terabyte collection, a few 100,000 photos, it's, well, quite a lot, but luckily we have to do it only once because we can store the result in DynamoDB. And also there's a free tier, so you can get 5,000 photos per month for free for the first year that your account is alive. So how does the solution look right now? So we copy the files on network drive. The Raspberry Pi is handling the syncing. Then we run the recognition, the Lambda function, and then store all the data in a DynamoDB. And then with help of Amplify and React.js, we have this photo browser. And because everyone loves architecture diagrams, here's one I made. So we copy the files on Raspberry Pi, raw files go into deep archive, and the preview images go into regular S3 bucket. Then there's a trigger, so whenever a preview image appears in a bucket, it will trigger a Lambda function that will run recognition for faces and objects, and then store the data into DynamoDB. And then when we want to browse those images, we have a Lambda function and an AppSync connected. And then, yeah, we have a photo browser for the web. And I've actually built this. So here's a live demo. So here we have all the galleries that are now synced here. Well, as you see, the images are blurry. It's because, well, I've added a CSS filter on these because these are real images from real photo shoots, and I don't want to show any customer cases for you that clearly. So here, for example, we can choose this photo shoot. We can see all the images from that one. Then let's select here. So the recognition have recognized that there is clothing, shoes, persons, female, and wedding. So we can choose all the pictures from weddings. So here's first we can see all the galleries that contain pictures from a wedding, and then all the individual photos that are related to weddings. And here, if we select one of these photos, recognition have found 65 persons from this picture. So I can select a face from here. Let's choose the redhead because it's easy to recognize even on a blurred version. So here we see that she's only in this one gallery, and here's all the pictures where she is appearing. Yeah, so that is how the application is looking like at the moment. So the total cost for this all, as I said earlier, this should be cheap, around 10 to 20 euros per month maximum. For this raw image that we have in Glacier Deep Archive is around $5 per month. Running the recognition after the first run, it's around $0 to $5 per month, depending how many photo shoots Eija has. Then these preview images on a S3 bucket is around $1 per month. And DynamoDB, all the traffic, Lambda functions, whatever the rest of the services we are using is around 50 cents per month. So the total cost is way less than 10 euros. So great success once again. Time spent, my own time spent, well, it's priceless, countless of hours figuring out this all, but it was definitely worth it. This was really nice learning curve, and there's lots and lots of components that I can also use on billable work here at Nordcloud. So that was my journey on backup solutions, organizing photos. You can follow me on Twitter, on GitHub with handler Arto Liukkonen, and now it's probably some time for questions. Thank you.